Now for this question, what I've done is I've copied out the graph that we're given of y equals f of x, and it's got a maximum here at the point A with coordinates 2, 3, and it crosses the y-axis, we're told, at this point where y is 1. And we've got 3 questions then, and we've got to sketch these 3 graphs based on the graph of y equals f of x. So how do we do part 1 then? We've got y equals f of minus x plus 1. So first of all, what we do is we look at what f of minus x would do to any graph. And f of minus x produces a reflection of the original graph, y equals f of x, in the y-axis. So here's our graph then of y equals f of x, and what we've got to do is reflect this in the y-axis. So this point here at 0, 1 is going to remain invariant, it's not going to move. So let's just see what it's going to look like. If we were to reflect this, we'd get this particular graph. And as you can see, this point remains invariant. And this maximum, A at 2, 3, has now moved over to this point, which is now at the point minus 2, 3. And what would this do now to the graph, adding 1? Well, it translates the graph, it translates it parallel to the y-axis. So what it does is it moves it up, okay, by 1 unit. So if this was at 0, 1, it's going to move up now 1 unit, and it's going to go up to 0, 2. And this point here, the maximum, which was originally at 2, 3, it got mirrored across the y-axis to minus 2, 3, goes up 1 unit, so it'll be now at minus 2, 4. So what we need to do is just update our diagram here. So this point here will now be at 0, 2, because it went up 1 unit, and this point here, our new A, will have coordinates minus 2, 4. Alright? So there's our graph then of y equals f of minus x plus 1, based around the original graph of y equals f of x. Now for part 2, we've got to sketch the graph y equals f of x plus 2 and then plus 3. So we start with looking at f of x plus 2, and what this does to any graph of the form y equals f of x is to translate it 2 units to the left, parallel to the x-axis. So our graph here, let's just overlay it with this graph here. What's going to happen is it's going to translate 2 units to the left. So this point here, A at 2, 3, now gets shifted across, and it peaks now on the y-axis. And then what we do next is we add 3. So it translates the graph 3 units up. Remember, this one translated the graph 1 unit up. Now we go 3 units up. So if we now move this 3 units up, let's just say we go up to a point, say there. So where is that point? Okay, well, what we've got was that this originally was at the point 2, 3. It shifted to the left by 2 units, so it's on the y-axis at 0, 3, and then we moved it up 3 more units. So this point here must be at 6, 0, 6. Okay? Now for this last one, y equals 2f of 2x. What we do is we start with f of 2x, and what that does is it takes the graph of y equals f of x and it stretches it parallel to the x-axis by a scale factor of half. In other words, what happens is that this point here, the point A at 2, 3, it stays exactly the same height, but the distance from the y-axis, which was 2 units, gets halved. So it peaks now at the point 1, 3. This point stays invariant. This point on the x-axis goes half this distance. It crosses about here, say. This point down here is about half the distance away from the y-axis, which will be about there, say. And what about this point? This point comes in by half, where it dips down here. That comes in by about half. So you've got a graph then of f of 2x looking something like this, coming down like so, peaking there, and then dropping away like that. Okay, something like that then. That's the graph of f of 2x. Then we've got to multiply this by 2. And so what happens now is that the graph of f of 2x gets stretched by a scale factor of 2 parallel to the y-axis. So this point here at 0, 1 now gets moved to 0, 2. Let's say that's about there. This point here, the maximum, remember it was originally here at 2, 3, it now is at 1, 3, and then we pull it out by a factor of 2. So instead of being at 1, 3, it is now at 1, 6. So we'll assume it's that point there. Let's just mark that in as the point at 1, 6. This point here then, where it crosses the y-axis, is at 2, 0, 2, and we've just now got to draw the graph in. So this point stays invariant, this point goes up by a scale factor of 2, so let's just say it's going to be about there. This dip here goes up by a scale factor of 2, so we'll say it's about there. So our graph is going to look something like this. Okay, up there, get a maximum here at 1, 6, falls away, and then it comes down through here, through this point, and then straight the way down. Not a great sketch, but I hope that gives you some idea then. We've got to mark in the point where it crosses the y-axis, so as I say, that's the point 0, 2. That's not necessarily the best place to put that 2, so I'm just going to take that out. We'll put the 2 there, okay? And we'll just fill that back in like so. So, hope that's given you some idea then how we're going to go about sketching these graphs.